Thermal chemistry application. So when a student mixes 50 mils of 1 moles per liter of hydrochloric acid and 50 mils of 1.1 moles per liter of sodium hydroxide in a coffee cup calorimeter, the temperature of the resulting solution increases from 21 degrees Celsius to 27.5 degrees Celsius. Calculate the molar enthalpy of neutralization for hydrochloric acid change in the reaction. And the total volume of the solution is 100 mils. Okay, seems like there's a lot of information, but it should be easy. So we need to list out everything that we have. HCl, hydrochloric acid, and NaOH, sodium hydroxide. The volume for HCl is 50.0 mils, and the concentration is 1.0 moles per liter. And for sodium hydroxide, equivalent amount, but concentration is slightly different, moles per liter. Okay. So in here, we have to assume that heat loss equal to heat gained. And that would be N delta HRM equals to MC delta T. MC delta T, that would be the water component, H2O. And we need the molar enthalpy of neutralization for hydrochloric acid. So we don't care about the NaOH. So that's the HCl part. So the N, the moles in here, automatically we know that it has to be HCl, the mole of HCl. And how do we find that? Well, we can go 50 mils, change it into liters, 1,000 mils, and then 1 moles per liter. And that would be 0.050 liters. I mean, moles. These mils are gone and liters are gone. So moles. So we have 0.050 mole delta HRM equals to the mass of the total volume. That would be 100 grams. How did I get that? Well, M 100 gram, because in here we use density, 1 gram over 1 mil. And then the specific heat capacity, that is 4.19 joules per grams degrees Celsius. And temperature, the change in temperature is 27.5 degrees Celsius minus 21.0 degrees Celsius. So now we can put everything into the equation, times 4.19 joules per grams per degree Celsius, and then 27.5 minus 21. So in here, we can go grams and grams, degrees Celsius are gone, and you can bring the mole over to the other side by dividing 0.05 on both sides, and you should be able to get delta RM. You should get 5.4 times 10 to the 4 joules per mole. and two significant figures because we have 1.0 as the least amount of sick days. And we're done.